So my dear children, now in this chapter we'll be discussing about the last and final effect given out by the electric current. So this effect is the chemical effect given out by the electric current. So I think you know about how electricity is being used in order to plate gold on certain metals, statues, and how we galvanize, right, iron. In the earlier lesson, I told you that during the galvanization process, we use a special thing called the electrolysis or electroplating. So here we provide electricity to a certain solution. And by that way, the solution is going to conduct electricity. When electricity is getting conducted from the solution, what happens automatically? A chemical reaction is going to occur. So this chemical reaction helps, right? This chemical reaction helps to plate whatever the material on the certain surface, right? If it is galvanizing, then on the bucket we can plate zinc. Okay, so this is how the galvanizing process is going to work. By providing electricity, we are plating zinc on the surface of the iron plate or iron bucket. So within this part, we'll be discussing how or what is the way of doing that process. So this process is referred especially as the chemical effect. Okay, electroplating process is the process which you used in that kind of a situation where we are using galvanizing. Now let's go and observe how to do this electrolysis process and what is this chemical effect given out by the electric current. So first of all, you are given, you can see a gas bubbling around a piece of a zinc dipped in diluted hydrochloric acid. It happens because of the chemical reaction between zinc and hydrochloric acid. So I think when we are discussing about the changes in matter lesson, I think that you could remember we use a piece of zinc and we put into a solution of hydrochloric acid. So in that case, you could observe that a gas is coming out. A gas is going to bubble out. So it's happening because of a chemical reaction which is going to occur within the system. When I'm going to put a metal like zinc, magnesium to a solution, especially to an acid, that metal is going to react with the acidic solution to produce a gas. Okay, actually that gas is hydrogen gas, but however those things are still not being learned from you guys, right? So therefore I'll just mention as gas bubbles. So gas bubbles are emitting out from the system when you add a piece of zinc or magnesium into a solution of hydrochloric or sulfuric acid. So here the acid is getting interacting with zinc or magnesium to provide or to produce hydrogen gas. So my dear children, within that activity which we conducted under the lesson changes in matter, it was very obvious to us that during a chemical reaction, during a chemical change, gas bubbles are emitting out. Color change can be occurred. A precipitation is going to come out suddenly from two solutions. Like that way we discuss several things, right, to provide a support to show that a chemical reaction has occurred within the system, right? So an example is given in the first step. When you put a piece of zinc to a solution of hydrochloric acid, what happens? A gas is going to bubble out. So in the next step it is given, acidulate about 200 milliliters of water in a beaker with few drops of hydrochloric acid. Dip 2 copper plates or rods which are connected to the terminals of a dry cell into this beaker. Now what you have to do? You have to take 200 milliliters of water and we have to put like several drops of acid. So that is referred as, if you add several drops of acid, so this water is called as acidulated water. Acidulated water means that we have to add only 2 or 3 drops, that's enough. For whole 200 milliliters, 2 or 3 drops is enough. Okay. So acidulate about 200 milliliters of water in a beaker with few drops of hydrochloric acid. Dip 2 copper plates or rods which are connected to the terminals of a dry cell into this beaker. And now what do you have to do? You have to take 2 copper plates and you have to dip those 2 copper plates into the acidulated water solution. Then you have to interconnect those 2 terminals with a dry cell, with several dry cells, or else you have to provide at least a good amount of electric current, like 9 volts, that's good, right? Then you have to observe what's going to happen here. You can see a gas bubbling near the plates. Here the electrical energy is converted to chemical energy. This phenomenon is known as the chemical effect of electric current. Now the specialty here is that, my dear children, when you are providing electricity to the solution means here the acidulated water through the copper plates, what will happen here is, like in the earlier case where we are going to use zinc with the hydrochloric solution. When you are going to add zinc with hydrochloric solution, I told you that gas bubbles are going to emit, and I told you especially that this gas is hydrogen gas. However, the observation is quite simple. Gas bubbles are emitting out when you add hydrochloric acid with zinc or magnesium. In the same way, you take some water, add few drops of acid into it, take 2 copper plates, dip in that solution, connect the 2 copper plates to a dry cell and observe. Like in the same way, in the earlier case where you're going to add zinc with hydrochloric acid, in the same way, gas bubbles are going to emit from the system. We know that if gases are getting created, definitely that should be a chemical reaction. It's because that chemical reactions are creating new substances through the rearrangement of particles. Earlier there was no gases, but however, after providing electricity only, gases can be observed. After providing electricity only, gases can be observed. In that case, my dear children, we can finally conclude that within this activity, or when I am going to put, or when I am going to conduct electricity through the solution, through the acidulated water solution, automatically within the system a chemical change is going to occur, but only when electricity is being provided. So therefore, from this activity we can finally conclude that when providing electric current to a circuit, what happens? A chemical reaction, a chemical change is going to happen or is going to occur. Right then, so this is the basic idea about the chemical effect of electric current. In chemical effect, it's really simple. What's going to happen in mainly is that upon providing electric current, or when you are going to provide electric current to an acidulated solution, right? In here, in this case only an acidulated solution, automatically that acidulated solution or acidulated water is going to provide gas bubbles. So thereby we can conclude that a chemical reaction has got occurred. Right then, not only emission of gases, there are other certain instances, there are other certain evidences that we can provide in order to show that a chemical reaction has occurred in the system. So we'll be investigating those things as well. But however, now let's head on to see the first activity related to the chemical change in electric current. That is this activity which is given in here. So let's see how to conduct that thing. So my dear children, now we are about to investigate or to identify the chemical effect of electric current. Now in this activity, you will be needing these materials. You will be needing a beaker, dry cells. It's better to use at least 2 dry cells or else to provide a good flow of electric current so that we can do the this process, or we can observe the necessary things quite fast if we use a 9-volt dry cell. Okay, we'll be needing carbon rods. Carbon is a good conductor of electricity. Carbon is a good conductor of electricity. Actually, carbon rods means here the graphite rods. Battery terminals are made up with graphite rods. Dry cells, in dry cells, not actually batteries, dry cell terminals. Now within the dry cell you can observe these carbon or graphite rods. Using copper is also okay, but however there is a difficulty in using copper because most of the times if you use a thin layer of copper, the positive terminal will dissolve. Okay, so therefore it's wise to use carbon rods. Okay, carbon rods. So most of the times when we are providing electricity, in order to create a chemical reaction within a solution, we use carbon rods because carbon is not going to interact with the solution. That's why. Normally metals are interacting with other solutions when electricity is being provided. There are some other metals which are very less reactive and those things are not going to interact with the solution, like platinum. Right? However, these things are very expensive. Platinum is also referred as white gold. That is the most expensive metal on our earth, white gold. The second most expensive one is the gold. So white gold is even more expensive than gold. But however, white gold is not interacting with those solutions. So we can use platinum or white gold rods in these cases. But however, if you use copper rods, copper or copper plates or copper rods will definitely interact with the solution. So we can't get somewhat clearer observations in that case. Okay. So in order to get a clearer observation, here we have to use carbon rods. Right? Here we are using carbon rods. So my dear children, carbon rods. Then we'll be needing acid. It can be hydrochloric, or sulfuric, whatever. Hydrochloric or, right, hydrochloric or sulfuric solution, acid solution. Then we'll be needing connecting wires in order to connect dry cells with the terminals or the carbon rods given here. Connecting wires. So these are the materials that we need, my dear children, right? So you are given with the steps in how to conduct the activity. So clean the carbon rods using a sandpaper. Connect 2 wires to the caps of the cleaned carbon rod securely. Connect the other ends of the wire to the set of dry cells. Then dip the carbon rods in the beaker of acidulated water as shown in the figure. Right. So first of all, you have to take that beaker and add like 200 milliliters of water. Then take that acid drops and add some acid drops into the beaker to make it acidulated water. Then after that, you have to dip the 2 carbon rods securely onto the beaker. Make sure before dipping to clean the surface of the carbon rods. Okay. Then after that, what you have to do? You have to connect the 2 carbon rods to the dry cells according to the figure. with the use of connecting wires. Okay, so this is the setup and this is how to conduct the activity. It's really simple, my dear children, right? Once again, see, clean the carbon rods using a sandpaper and connect the two wires to the caps of the clean carbon rod securely. So at the end there are two caps, right? Those caps are helpful to fix connecting wires onto the carbon rods. Then what you have to do, connect the other two ends of the wires to the set of dry cells, then dip the carbon rods in the beaker of acidulated water as shown in the figure. So first of all, you have to take that beaker, put some water into it, get few drops of acids, mix it with the water, then after you have to insert the carbon rods. Remember, my dear children, when you are inserting these carbon rods to the solution, make sure that they do not come in contact with each other. If they come in contact with each other, then the whole experiment would be faulty and you won't be able to get necessary observations. I mean, like if you touch these two together, then you can't get a such observation. Okay, remember that thing. In order to do this experiment well, you have to keep it like this. If you touch these two terminals together, if you touch the two rods together, then you won't be able to conduct this experiment. So when you are inserting the two carbon rods, it's important to place those things away from each other. Away means they should not come in contact with each other. That is very compulsory. Right. Then observe what happens when the dry cells are removed and both ends of the wires are connected together while the rods are still in acidulated water. So what you have to do now, you have to connect this thing. Then after connection, observe what's going to happen. Then remove a wire and after removing wire, observe what's going to happen. Likewise, connect and observe what's going to happen. Remove and observe what's going to happen. Okay, so this is the way of doing our activity, my dear children. Right, then let's head on to the lab and we'll conduct this activity. And let's see what are our observations when conducting this activity. Let's see whether the gas bubbles are coming out or not as per to the theory that we studied. So my dear children, within this activity we will be investigating the chemical effect given out by electric current. Means that by providing electric current, we can result a chemical reaction or else a chemical change. Right. So to do this activity, first of all, we'll be needing like 150 milliliters of 150 to 200 milliliters of acidified water. Acidified water means, children, now I have added water and for that water few drops of, not a heavy amount, but few drops of acids, right? 2-3 drops of acids. Then after that I have a dry cell with me. So here I have used a 9-volt dry cell in order to provide good steady current flow. Then 2 carbon rods to provide electricity. So carbon is a good conductor of electricity, right? Carbon is a good conductor of electricity. Even though carbon is not a metal, it's going to conduct electricity very well. Actually, these carbon rods are made up with graphite. Graphite is made up with carbon. So these are graphite rods. Graphite is a good conductor of electricity even though it is a non-metal. So what I'm going to do here is now, I'm going to take the dry cell. First of all, we'll connect the 2 terminals to here. Number 1 and number 2. Then steadily I'm going to insert the 2 terminals. Remember, when you are inserting these terminals, make sure that they do not touch each other. If they touch each other, then you won't be able to get the necessary outcomes. So here we go then. Then after that I'm going to connect the second terminal. Then so here we go then. So as soon as I'm going to insert the carbon rod, you can see gas bubbles which are getting formed within the system. See, so I'm going to remove it then. So now I have removed both the carbon rods. See, there are no gas bubbles. Now let's insert once again and see what's going to happen. See, as soon as I'm inserting the two terminals, you can observe gas bubbles which are forming inside the system. So it's very clear to us that when I'm providing electricity to the circuit, actually to the solution, to this acidified water, there's a chemical reaction or else a chemical change which is going to occur. How can I say that? Because the gas bubbles are getting formed here. New substances are getting created from the earlier substances. So we can say that a chemical reaction has happened within the acidified water when current is passing through it. Now once again, let's head on to the classroom, my dear children. We'll write down our observations and conclusions. Okay, my dear children, now we conducted the activity. As I was explaining in the earlier slide, right? You could see very clearly when the electricity is being provided to the solution by carbon rods, we could see that gas bubbles are coming out from the solution. So if gas bubbles are coming out from the solution, we can conclude a chemical reaction is going to occur within the solution. That's why new substances are getting created. Now in the earlier case, when I was not turning on the switch or not connecting the wires to the dry cells, at that case there was no gas bubbles. Solution remains the same as it is. But however, when I am providing the electricity, we could clearly observe that gas bubbles are coming out. So presence of gas bubbles or emission of gas bubbles confirms the presence or the activity which occurred within the solution. So that activity is a chemical reaction, right? So we'll write down our observation and conclusion, my dear children. Our observation is quite simple. Gas bubbles are given out when connecting wires to the dry cell, right? So gas bubbles are given out when connecting wires to the dry cell. When connecting wires to the dry cell, we could clearly observe that gas bubbles are given out. So by this observation, we can come into a conclusion. What's our conclusion? It's really simple, my dear children. Upon providing electricity to the acidulated water, a chemical reaction upon providing electricity to the acidulated water, a chemical reaction was chemical reaction is observed. So upon providing electricity to this acidulated water, a chemical reaction is observed, right? Chemical reaction is resulted. So this is our final conclusion from the activity. So it's happening only when electricity is being provided to the circuit. That's it. If electricity is not there, then it's not going to work at all, right? So upon providing electricity to the acidulated water, a chemical reaction is observed, right? Right, so the next topic is given, my dear children, the electroplating process. So here it is given, a metal can be plated on metallic object using the chemical effect of electric current. Now we use this chemical effect of electric current in order to plate a different kind of a metal on a certain type of a statue or else an object which is made up with another kind of a metal. For an example, let's imagine that I have a gold plated medal, gold medal. That gold medal is not 100% gold. Most of the times gold medals are made up by plating gold on a copper or any other kind of a medal. Okay, that's how the gold medals are being created. We are plating it. Those things are not 100% gold. We are plating it. Okay, so that plating process is conducted by using the process or by using the thing or the phenomena which is referred as the electroplating. This electroplating process is related with the chemical effect given out by the electric current. We utilize the chemical effect of electric current in order to provide or in order to electroplate a certain type of a metal on a different kind of a metal. So my dear children, it's really simple. Now let's see how to plate or how to do this electroplating thing. So here you are given, so a metal can be plated on metallic object using the chemical effect of electric current. This is known as the electroplating. So this method is the one which is referred as electroplating, plating a metal by using the chemical effect of electric current. Some examples of its usage are given below, right? So there are some examples. Let's see what are the examples. Number one given, plating gold or silver on jewelries. Now there are certain types of jewelries. If you go to a jewelry market or to a shop, you can observe jewelries under different price levels. If you go for a very less price necklace, most of the times the necklace is plated with gold. It's not 100% gold. It's been plated with gold. So to plate gold on a certain jewelry items, we use the electroplating process. Sometimes when you are wandering around the streets, you have observed the areas, right, that do this kind of a electroplating thing. Near a road, there's a basket-like thing, right, and a person is like cleaning a certain type of a a necklaces, and he's got a huge solution. He's placing that thing on the solution by using copper wires or copper strings, thicker ones, then connecting to a dry cell. By that way he's going to electroplate. In normal streets also we can observe these things, right? In jewelry shops also, these guys or these people are doing jewelry works. They are utilizing this chemical effect to plate gold or silver on a particular jewelry item. Then in the next one it's given, so plating metals like chromium or nickel on equipments like spoons, forks, knives, bathroom sets made up of iron to prevent rusting and to give them an attractive appearance. Now, in plating metals like chromium, now you know that there are bathroom sets with chrome color. They have an attractive look, has a shiny nature. Now all of these things are made up with iron, but however, the usual color of iron is way more different than that. The chrome color, that unique silver lustrous, unique silver color, the chrome color is given out by those bathroom sets or any other material. It's because that the chromium metal is being plated on that certain instrument. So to plate chromium or nickel metal on these types of instrument or materials like bathware items, knives, forks, we use the electroplating method. Then plating tin inside iron containers used for canning food. So plating tin inside iron containers used for canning food. Now you know that to avoid the rusting of iron, either we can galvanize or else we can coat it with tin. Tin is a special kind of a metal that we use in our day-to-day life. So to plate tin on iron, we can use the electroplating method. And in also galvanizing process, remember my dear children, in also galvanizing process, we use this electroplating method. So these are the methods that we use in our day-to-day life. The chemical effect of electric current, and this effect is also named as electroplating. Like in the earlier case, where we just provide electricity to give out a certain chemical effect. Like in the earlier case, which we use acidulated water and we provided electricity, gas bubbles were emitted. So that kind of a one is referred as electrolysis. Electrolysis, providing electricity to result a chemical reaction. So we are providing electricity to result a chemical reaction. If you provide electricity to provide or to get a chemical reaction, such a thing is referred as electrolysis. If you specially use this electrolysis process, means if you specially use this provision of electricity to get a chemical reaction, but to plate a certain metal on a certain different kind of a material, that one is referred as the electroplating. Commonly, the chemical effect given out by electric current is referred as electrolysis. If we are plating a metal, then that is referred as electroplating. Okay, both the things are same, but however, a special term is given as electroplating if we are plating a metal on a certain surface. Right. So my dear children, these are the uses of electroplating. Plating gold or silver on jewelries, then plating metals like chromium, nickel on equipments like spoons, forks, knives, bathroom sets and any other materials to prevent it from rusting. Then plating tin inside the iron containers, which is used to can food. And also in galvanizing processes also we use this electroplating method. Right then. So now we are going to do an activity in order to investigate about the electroplating. So here we are identifying the process of electroplating. We will be needing these materials, my dear children. We will be needing a beaker, right? Then dry cells to provide good electricity. You will be needing a copper sulfate solution. Copper sulfate solution. Then we'll be needing this one here, a copper plate, and we'll be needing a metallic item like a spoon or else an iron nail. So iron nail is the next one. We can use even a spoon or else a fork. We can use a spoon, a fork, an iron nail, whatever a metallic material, right? Now we are going to plate copper. We're going to plate copper on this item, the iron nail, spoon or the fork, right? You can use any of these materials. So we are going to plate copper on these instruments, one of these instruments, right? Right, now let's see how to conduct the activity. So here it's simple. Add copper sulfate solution to the beaker. Connect two connecting wires to the copper plate and iron spoon securely. Connect the free ends of the two connecting wires to a set of two tricells joined in series. Then dip the copper plate and the spoon in the beaker of copper sulfate solution. Observe the spoon after a while. So my dear children, this is the activity. First of all, you need to connect the copper plate to a connecting wire. Then you have to take the iron nail or the spoon, right, to the negative terminal or with another connecting wire. Then you have to insert the spoon onto the copper sulfate solution. Then after, spoon should be connected to the negative terminal. Always remember, the object should be connected to the negative terminal. Always remember that thing. Object should be at the negative terminal. Definitely, the object should be at the negative terminal, and metal plate that we are going to use, in order to plate that metal on the object, that one should be on the positive terminal. This is very important. If you interchange these two, then our desired observation will not be obtained. Remember that thing. Always, all the time, object should be at the negative terminal, and the metal plate, whatever the metal plate that we are going to use the plate, right? Now we are plating a metal on an object, no. So the metal plate that we are used to plate on the object should be used as the positive terminal. This is really important, my dear children. Okay, right. So connect the free ends of the two connecting wires to a set of two tricells joined in series. Then dip copper plate and the spoon in beaker of copper sulfate solution. Then you have to insert it like this. Make sure that they do not come in contact with each other like in the earlier case, where we use the acidulated water solution. If they come in contact with each other, then the whole experiment would be a faulty one. Okay. So what you have to do, you have to leave it for some time and observe what has happened with the spoon. Okay. Leave it for some time and observe what has happened with the spoon. So this is the way of conducting the activity, my dear children, right? So now let's head on to the lab and we'll conduct the activity, and let's see what is going to happen with the spoon when I'm going to leave this system for a while. So my dear children, within this activity, here also we are investigating about the chemical effect given out by the electric current. But however, what I'm going to do in this time is, I'm going to use that electrolysis process in order to plate copper on the spoon that I have in here, right? So first of all, I have a copper plate with me I have scratched it by using a sandpaper. Then I have a copper sulfate solution. So if I'm going to plate copper on a certain surface, I have to use a sulfate or else a solution of copper. So here in this time we have used copper sulfate solution. Okay. So this is my positive terminal now. As the positive terminal, I have to use this metal plate which is copper. So I'm going to insert this into the system. Then let's connect it with the positive terminal of the dry cell, the red color one. So my dear children, the other case is that it's important to not to touch with the negative terminal, right? Negative terminal is now my spoon in here. So I'm going to insert, so you can see there are no any other metals which are plated on the spoon. You can see it very clearly, right? There's nothing in here. So I'm going to insert it and make sure that they do not come in contact with each other. Then we'll connect it with the negative terminal of the dry cell here. Right. So we have to wait for a while. Now if you check the spoon in here, you can see that there are gas bubbles which is getting created. So we'll wait for somewhat time and let's see what's going to happen. Right, my dear children, now let's see what has happened here. So as you can see here, it's very clear to us that there is a copper color, like brownish color substance on the spoon. See? So there is a brownish color substance, right? I can wipe it off by using, right, a tissue paper. I'm going to wipe it off. See? So this substance is copper, right? So copper is getting plated on the spoon. Once again, I'm going now. Let's remove the stain like this. And once again, I'm going to show it to you. So here you can observe it very clearly. See? So let's wipe it off. So I have wiped it off. So let's insert it once again. Right, so I'm going to take it off. And you can clearly observe once again, there is copper around the spoon. See? Right, so I can remove it by using this. See? So there is a clear stain. You can see it very clearly. There are two different colors. See? Right. So here we can finally conclude that within this system, when I'm going to provide electricity for the copper sulfate solution, for the copper plate over here at the positive terminal. On the negative terminal, we can plate copper, right? So always the object which the metal needed to be plated, it should be in the negative terminal, while as the positive terminal, you have to use a metal rod or else a metal piece that we are going to plate should be on the positive terminal. Okay, so if you are plating gold, then we have to take a piece of gold as the positive terminal, and the negative terminal, whatever, a necklace or else a jewelry, right? So this is how the plating process is being conducted even in the industrial level. So it's really simple, right? So this method is referred as electroplating. Here also we provide electricity in order to get, or in order to give out a chemical effect, right? So let's head over to the classroom once again and write down our observations and conclusions from the activity. So my dear children, we conducted the activity and you could see that there was a clear stain of copper on the spoon. Even when I'm touching the spoon, that layer of copper is getting contact in my hand as well. So it's really simple. That activity, the electroplating process, is very simple. Only thing that we need to do is get a solution, a good solution that has the metal which we need to plate, and take the plate, take a plate of that metal that we need to plate the object. So after that, you have to take the plate as the positive terminal, object as the negative terminal. Dip those two in the solution, provide electricity to the two terminals. Make sure plate is connected to the positive terminal, object is connected to the negative terminal. By that way, the necessary metal or the metal plate will dissolve in the solution and it will gradually get plated on the object. So this is how the electroplating process works. But remember, when you are electroplating, it's important to use a solution. Actually, it should be a salt, right? Now, if you are plating copper on an object, you have to use a solution of copper, salt solution of a copper, like copper sulfate. If you are plating, let's say gold, if you are plating gold, then you have to use a solution like gold chloride or gold sulfate as the solution, and as the positive terminal you have to use a piece of gold, plate of a gold. If you are plating silver on a certain surface or on a certain metal object, you have to use silver chloride or silver sulfate as the solution. Then a piece of silver as the positive terminal, whatever the object as the negative terminal. Then you have to provide the electricity. So according to the metal that we are going to plate on the object, the solution is also getting changed. The metal plate that we need to use as the positive terminal is also going to change. Now here we are plating copper. So therefore I have used the positive terminal as copper plate. And the solution is also should be a solution of copper. Mainly we are using sulfate solution, a sulfate solution. Not sulfate solution means not only like copper sulfate, there are other sulfate solutions as well, like sodium sulfate, calcium sulfate, magnesium sulfate, gold sulfate, silver sulfate, like that way there are different sulfate salts. So my dear children, it's really important to use a good salt, right, like sulfate salt of the necessary metal that you are going to plate on the object. Okay, so that is really important. According to the metal that you are going to plate, right, the solution also going to change. The positive terminal is also going to change. Remember that. Right then, so we'll be writing down our observation. Our observation was quite simple. Copper has been plated on the spoon. That was our observation. It's really simple. By looking at the stain, looking at that brownish color nature, we can say that it is copper. So copper has plated on the spoon. Copper has plated on the spoon. So our conclusion is really simple. Chemical reaction here, especially electroplating, right? Chemical reaction here, especially electroplating, has occurred within the system. That is why, my dear children, copper is going to plate on the spoon. The position or the copper materials is changing their position, the copper materials or the copper particles are going to rearrange to a different place and it's going to plate on the spoon. That's how this whole process of electroplating is going to work. They are rearranging their places in order to form new substances out of the solution. Okay, right then. So the observation is quite simple. Copper has plated on the spoon, and the conclusion is chemical reaction or the electroplating process has occurred within the system, right? By touching the surface, by looking at the surface of the spoon, we can say that. Right, my dear children. So this is how to conduct the electroplating process. But make sure, remember, this is really important. According to the metal that we are going to plate, right? According to the metal that we are going to plate, the positive plate or the positive terminal which is attached with the plate is going to change, right? The metal plate is going to change. And the second one is that the solution we are going to use is also going to change according to the metal that we are going to plate on the object, right? If it is gold, then you can't use copper as the positive terminal. Then you have to use a gold one, right? So this is how the electroplating works. So my dear children, with that electroplating thing, we come into the conclusion or the final stage of the lesson. So we have discussed several effects given out by the electric current. First of all, we discussed about the heat effect, then we discussed about the lighting effect, then third, the magnetic effect, finally about the chemical effect. The four effects given out by the electric current. So my dear children, we came to the finish of our lesson right now. So let's head on with the summary and let's see what are the things that we studied under this lesson, electricity. So first of all, we studied bulbs can be connected in series or parallel connection. So we studied that electrical components can be connected in a series connection or else in a parallel connection, and we have studied about what do you mean by the series connection and what do you mean by the parallel connection, right? We have studied about the series and parallel connection quite well, and even we made circuits, even we made several circuits related to the parallel systems and series systems. Then cells can be connected in series or parallel type to supply electricity to the circuits. So we studied that if you are going to connect cells in a series connection, voltage is going to increase. If you are connecting cells in a parallel connection, the same voltage is provided to the circuit but for a longer time period, right? Series connection of cells and parallel connection of cells to the circuit. Then There is a simple electric circuit in the electric torch. We studied about the simple electric circuit. Under that we discussed about the electric torch, right? We discussed about the electric torch. Then, my dear children, switches and resistors are current controlling components. We studied about switches. We studied about the resistors, right? And we studied that switches and resistors can be used as current controlling equipments. Means that we can use these equipments in a circuit in order to change the current flow, right? Mainly switches are being used to cut the current flow or else to provide the current flow when it is needed. Resistors are being used to change the amount of current flow in a circuit, right? To change it to a desired value, we use the instrument called rheostat. To vary the current, we use variable resistors, right? Variable resistors. And in order to change the current to a fixed and permanent value, we use the permanent resistors. Then after, we discussed that tap key, plug key are two types of switches. So we discussed about the several types of switches. Then after, about the plug key and about the tap key, right? Fixed resistors, variable resistors, rheostat and light dependent resistors are also current controlling components. Then we studied about several types of resistors, my dear children. We studied about permanent resistors and the nature of permanent resistors, how to identify a permanent resistor, how to connect a permanent resistor to a circuit, how does the value of these permanent resistors are being concerned, or how the value is getting calculated. Actually, we never done the calculation, but I told you that the value can be found out by the body colors, the color stripes on the body, right? Then we discussed about the variable resistors, especially we discussed about the rheostat. So we use the rheostat in order to change the current in a circuit to a desired value. The slider at the top of the rheostat is being utilized to change the resistance. Then we discussed about the LDRs, light dependent resistors. So we used the light dependent resistors in order to change the current in a circuit, but according to the amount of light which is being received, right? According to the amount of light which is being received, we can control the resistance in the circuit. By that way, we can change the current which is going to flow inside the circuit. So that's all about with the LDR then, right? According to the intensity of light, resistance is getting changed in an LDR. By that way, current is getting changed, right? Equipments used to perform work using electricity are called electric appliances. So in our day-to-day life, the things or the instruments, electrical appliances, right? Or the electrical instruments. In day-to-day instances, we use these things. Electrical appliances are the ones that we use in our day-to-day life to make our work easy. So, for examples, we can take radio, television, air conditioners, refrigerators, and so on. There are several types of electrical appliances at our home, and we discussed how to select the best and most efficient household electric items like rice cookers. When you are selecting rice cookers, when you are selecting a refrigerator, an air conditioner, when you are selecting light bulbs, like that way we discuss several things related to the household electrical appliances, household electrical circuits, how it is going to work, and what are the current saving methods. Like that way we discussed several things, and after that we discussed about the precautionary methods or the precautions that we can follow in using these electrical equipments or household electrical equipments, and so on, right? So we discussed about the household electrical equipments in the next part. Then after that we discussed about some electrical appliances which use the heat-in effect, right? So some electrical appliances use heat-in effect of electric current to generate heat. So after that, we have discussed about the 4 different types of effects given out by the electric current. First of all, we discussed about the heat-in effect given out by the electric current. So there are some electrical appliances that use that heating effect of electric current. Examples are electric heater, geysers, right? Then after, hot plates, electric bath, rice cookers. All of these instruments utilize the heat energy generated by the electricity. So mainly this heating effect is given out because of the resistance of the material, and nichrome is the core which is being used as the nichrome is the core of heating instruments, right? So in these instruments which generate heat energy using the electricity, as the core, as the heating core, we use nichrome because nichrome has a higher resistance than the other materials. Then we discussed about the lighting effect, right? So light emitting diode or LED is the component that we use in lighting effect. So light emitting diode is a component that used in lighting effect of electric current. So to identify the lighting effect, we use the light emitting diode. So those are special kind of a junction diode. Instead of converting electricity into heat energy, these junction diodes, LEDs, are going to convert that electrical energy into light energy. That's why those things are called as light emitting diode. When the electricity is passing through the junction, automatically the junction is going to light up, or it's going to illuminate by giving out a light, okay, LEDs. So second effect of electric current was lighting effect given out by the electric current. Then the third step, electromagnet is a component that uses magnetic effect of electric current. So the third effect was the electromagnet thing. Here the magnetic effect is the one which is given out when these things are getting connected to electricity. Especially when you connect an electromagnet to electricity, the magnetism is given out. When you connect a conductor to an electric circuit, we could observe that a compass is going to deflect because of that magnetic field created around it. So electric bells, cranes, weight lifters are the ones that are going to use this magnetic effect of electric current. Most of the times these things are used in temporary magnets or electromagnets. Then finally we discussed about the chemical effect given out by the electric current. So here the strength of an electron, before that we discussed, when you are taking electromagnet, the strength of the electromagnet is going to depend on several factors. So it is given here, the strength of an electromagnet depends on the type of the core in the coil, the electric current flowing through the coil, and the number of turns of the coil. So strength of the electromagnet is depending on the current flow, the core which is present within the coil, and the number of turns or the length of the coil, right? These are the three factors that affects the magnetism created in an electromagnet, okay? Then after we studied finally about the electroplating and the electrolysis process. So that's regarding with the chemical effect given out by electric current. So electroplating is an instance where the chemical effect of electric current is used. So chemical effect of electric current is mainly used in the process called electrolysis or the electroplating process. So my dear children, these are the key things that we learned under the electricity lesson, right? So we have come to the end of the lesson, my dear children. So within our next chapter, we'll be discussing several questions related to this lesson, electricity. Okay, so I hope that you would stay with me with the questions also. So I'll hope you to meet within our next chapter to discuss several questions regarding the electricity lesson.